Boom! Alright, so welcome to another video in our series on vectors. In this video we're going to deal with the whole question of adding vectors and subtracting vectors, if you want to call it that. Remember, earlier on in our series we dealt with the case where we had three vectors that were traveling in the same line, same magnitude, same direction, which, based on what we ended the last video with, we now know that these three vectors would be collinear because they have points in common. Alright? And we also would have discussed the fact that we would have called this A, this was A, this was another A. And we would have also discussed that moving in the opposite direction, same orientation, opposite direction, means that instead of plus A, we have minus A. Alright? Of course, the minus sign signifying a reversal of direction. Yes? So, how do we apply this in the case where the vectors are not collinear? So how do we add vectors that are not collinear? Alright, well, let me see how we're doing that. Alright? So if we have two random vectors, if we have a vector A and a vector B, right? How do we add these vectors? If that's A and that's B, right? That's vector A and that's the vector B. How do we add A plus B? Well, the fact that the lettering is different suggests immediately that B is not the same thing as A. If we had A plus A, it would be what we have here, A plus A, which would be 2A, which is the same thing as multiplication. Alright? But the very fact that we use a different letter says to us that the vector is not the same thing as A. So how do we add that? We add it by simply traveling along the entire length of A, and then at the end of A, we take B and we bring it like that. So that's the same A and that's the same B. So in other words, we travel in the direction of A and then we travel in the direction of B, and that is A plus B. Now, A plus B, starting from here and traveling in the direction of A, and then having gotten here, moving in the direction of B, is the same thing as starting from here and going straight across to here. So in other words, this line here represents the vector A plus B. And that is all it is really. Alright? So you're adding the vectors by simply traveling the distance travel the distance and the direction denoted by the first vector, and then do the same thing for the second vector. No problem there either. Now, how do we minus vectors? If we want to denote A minus B, same story. We start with A, and well, let me make that A now, right? That is A, and instead of going in the direction of B, so this is A, we're looking for A minus B, right? So this is A, but instead of going plus B, which would be the direction of B, we go in the opposite direction. So this would now be A, right? So this here is minus B. So from here to here would be A minus B. Yeah? This would be A. This vector here will be the vector A minus B. And that's basically it, you know. Now you realize that different triangle here as opposed to here. But that's the nature of the game. Right? So in other words, You could add or subtract any two vectors or any amount of vectors by simply paying attention to the direction. So when we add in vectors, the magnitude is not as important as the direction. Right? If we add in scalars, then a scalar is just a scalar. A scalar is just quantity. Right? So 5 plus 3. So in other words, if the magnitude of A is 3 and the magnitude of B is 4, A plus B wouldn't necessarily be equal to 7. The only time that A plus B will be equal to 7 is, guess when? If A, well, no, that wouldn't happen because B is in a different direction. B is a different direction. So the whole question of collinearity wouldn't arise at all. All right? Yeah. So in vector addition, 3 plus 4 is not equal to 7. Right? And the reason for that is because we have to take the direction into account. And the sheer fact of having to take the direction into account means that the magnitude wouldn't add. The magnitudes wouldn't add in the same way that a scalar would add. So depending on the relative directions of these things, A plus B, the magnitude would not necessarily be equal to 7. You'll have to do other mathematics to find the magnitude. But the direction, however, will just be A plus B if we talk in direction. So in other words, and again, same story here. If A is, the magnitude is A and the magnitude of B is 4, then the magnitude of minus B is minus 4. We cannot say that 3 minus 4 is minus 1, right? Because of the whole issue of direction. So vector addition and by extension vector subtraction is much more about direction than it is about magnitude. Right? So that is something to keep in mind as you go further on. Right? And if we want to add another vector, let me say this is the vector A. Let me define the vectors now, man. This is the vector A. This is the vector B. And let us say, let me say this is the vector C. Right? So if you want to say A plus B plus C, A plus B plus, that will be A. Let me change the color. That will be A plus B, and then they go plus C. C is down, right? And of course, that would be the same thing as, let me say C was a little longer, just for the sake of explanation. In fact, no, B is actually a little longer. So we shortchange the B, man. So as a B and as a C. Right? So it will be the same thing as moving from A to C. So this is A, this is B, and this is C. C, B, A. This guy here so in other words, from here to here would be A plus B plus C. So again, vector additions is about direction. Vector addition essentially is about where you start and where you finish. Where you start and where you end up. And we could have any combination of A plus B and C where we reverse the direction of any of these three. And we will get we'll start in a particular position and end up in a particular position. So for example, let me say A plus B minus C, right? This is a A, there is a B, but C is going so. So minus C will be going so. So this is A, this is B, and this here is minus C. So this vector here, from here to here, will be the same thing as A plus B minus C. Alright? So vector addition is about adding directions, not adding magnitudes. It's about adding movement. One movement lead to another movement, lead to another movement. And the sum total of all those movements, the result of all of those movements, is that you start from here and you end here. So in other words, one movement, and we add to that another movement, and we add to that another movement, which is the reverse of a previously defined movement, and the result, or the resultant vector per se, if we want to borrow some terminology from physics. The result is the same as if we had started from here and gone straight across to here. So the result is A plus B minus C. A plus B minus C. In this case, we would have had A plus B plus C. It's the same thing as moving from here to here, A plus B plus C. So it doesn't matter how many vectors you have. Once you understand that addition and by extension subtraction is about movement. From one point, you go through a series of movements defined by particular vectors and end up at another point. So in the next video, what I'm going to do is do one more application of this same general idea. A very specific application, one that it is so important that if you have the ability to just write it off the top of your head, that will save you a lot of time in unit vectors questions. But even if you're not sure, even if you don't have it memorized, you could still go back to your foundations as we discussed here and derive it. So we're going to wrap up this video now. As always, get into that zone now where you're looking to do questions. Right? We have one last video in the discussion, and after that, the floor is yours.